And now we are going to explore 3D volumetric images. So let's bring it a little bit up. And now let's show the 3D volumetric image. So this is a slice from MRI, a 3D volumetric image. A 3D volumetric image is a representation of data in 3 dimensions. Instead of single 2D image, it is made of multiple slices of 2D images stacked together to form the third dimension. Here each slice corresponds to a specific layer or depth within the object. And here this is the image, which is a type of indexed image also. Here you can see its indexation and RGB intensity. Even when we're talking about indexed image, we have talked about images in X-rays and CT scan and MRI. So now here let me give you some information about this 3D volumetric image. This volumetric image are often captured using specialized imaging techniques, right? This is not a normal camera which is taking this type of images. And those techniques are like computed tomography scan, that is known as CT scan. The another one is magnetic resonance image, that is known as MRI. So the images that we get in CT scan and MRI is type of 3D volumetric image. Now, how is the structure of this 3D volumetric image? A volumetric image is stored as 3D matrix. Row X represents the width of each slice. Column Y represents the height of each slice, and slice Z represents the depth. So here if the image is 128 by 128 by 27, that means it has 128 numbers of row, 128 numbers of column, and there are 27 slices for entire 3D image. Now here we are observing 13th numbers of slice. Let's close it, make it 5 and run again. See, when you see the 5th numbers of slice, image will change. Close this thing, let's make it 25, run it again. And this is 25th numbers of slice. So when you change the numbers of slice, it will give you a different perspective. So there are total 27 slices, and by changing it you can observe them one by one. Now if we talk about the applications of 3D volumetric images, the first application is very simple in medical imaging like CT scan, MRI or ultrasound images. This is also being useful in industrial applications. There it can be useful to inspect internal defects in material using non-destructive testing. This is also being useful in geoscience. It will model surface layers in geology and seismic imaging. And this will also be useful in microscopy, where it is useful in studying fine scale of biological structures, because this provides a detailed internal view of object, making them essential in field like medical imaging, microscopy and geology. And the best part is MATLAB supports 3D data visualization and analysis, making this MATLAB tool such powerful that you can do all the analysis using MATLAB. And one of the example we can see over here.